Uh, Here in this video, we'll do some problems of differentiability, and I am assuring you that I am doing in such a manner that which is very easy for you at the time of exam. I am doing this problem because in your exam it is written that the instruction is there. Every teacher will give you full credit if you are doing in correct way. There are many ways to solve a problem. It's a different way. Fx is equal to, the question is fx is equal to mod x at x is equal to pi. At this point we will test the differentiability question. Now look at here. Fx is equal to, as we know, mod box is equal to anything mod is equal to that thing when that thing greater than equal to 0 and minus of that thing when that thing less than 0. This is the fundamental thing. Okay. Now mod sin x. What is mod sin x? Mod sin x is sin x when sin x greater than equal to 0. And so mod sin x is equal to sin x when this sin x greater than equal to 0, minus of this sin x when sin x less than 0. Sin x greater than, this is the graph of y is equal to sin x. Graph of what? Y is equal to sin x. And we know when x 0 to pi sin x is positive, when x 0 pi to 2 pi sin x is negative. Now I am writing, and my question is to discuss about the differentiability at the point x is equal to pi. Now sin x, I am writing fx is equal to sin x greater than equal to 0. Just I am taking this part where pi should be there. So x 0 less than equal to x less than equal to pi, and fx is equal to minus sin x when this sin x when this x lies between minus pi to 2 pi. Okay. Now very easily you can solve after that. Just you have to find f dash x, that is cos x minus cos x, and it is a very remarkable point. You should not put the equal mark here. 0 less than, you can write here, but actually you should not write. So I am dropping it. 0 less than x less than pi. For this problem you can put, but in general you should not put 0 less than x less than pi. It is minus cos x pi less than x less than 2 pi. Now what is left hand derivative? It is f dash pi minus, that is cos pi, which result is minus 1. Now right hand derivative f dash pi plus, which is minus cos x, which result is plus 1. Now so fx left hand derivative and right hand derivative, they are not equal. So fx is not differentiable at x is equal to pi. Now you should know what is the graph of fx is equal to mod sin x. That is very important. Now look at, for fx is equal to sin x, y is equal to sin x, graph is this. Okay, when mod sin x, then the positive part will be there, and this negative part, when we take the modulus, it becomes positive, so it will go to upside, so it becomes this. Upper side, if it is in positive side of x axis, then it remains. When it goes to the negative side of y axis, it will just go up. Okay, then the graph will be this, like this. And tell me the points where the function is not differentiable. Look, the points, find the points where it is suddenly changes its path. Certainly it is 0, pi, 2 pi, minus pi, the point, the junction points. Okay, in exam you should not do this. This part you should not do this. Up to this you should do. If you will do this, this is extra to extra. If it is extra to extra, then the examiner will think, ये बच्चा, ये लड़की और लड़का खूब जानता है. Okay, now I am going to problem number 6. I am solving this problem also in thoda hatke, not in traditional ways, which is very long, lengthy. Fx is equal to this at x is equal to 0. Fx is equal to x. 1 plus mod x is x, where x greater than equal to 0. Mod x is minus x when x less than 0. Just differentiate. I am not doing exact way. You should do. by applying u by v rule, v derivative u minus u derivative v by v square, it is 1 by 1 plus x square. Also differentiate this, it becomes 1 by 1 minus x whole square, and you should not put equal mark here. You should not put the equal mark here. It is x greater than 0, that is x less than 0. Now look at what happens when f dash 0 plus. For f dash 0 plus, you have to put 0 here. It becomes 1 by 1 plus 0 square. The result is 1. For f dash 0 minus, you should put 0 here because here x less than 0. F dash 0 minus, you have to go to this side and find that value. 1 by 1 minus 0 square, result is 1. Now f dash 0 plus f dash 0 minus. So differentiable at x. So the function, so fx is differentiable at x is equal to 0. Suppose the question will come about the continuity. First you show the differentiability. This implies fx is continuous at x is equal to 0, because every differentiable function is continuous. But if exam this question will arise about the continuity, you have to check it, and you can do it by yourself, which is very easy. Limit of fx extends to 0 and minus, then limit of fx extends to 0 plus. You can do it very easily. Okay, I am doing it. Look at me. For continuity, here limit x, I am taking right hand limit extends to 0 plus of fx, or extends to 0 plus, it becomes what? It becomes sin x, and when we put x is equal to 0, it becomes 0. Similarly, left hand limit fx in place of fx extends to 0 minus, means we have to put what? Fx is equal to, in place of fx, we can put minus sin x. So the result is what? Result is 0. For functional value, the result is also 0. Okay? I am taking it. Okay, I am extremely sorry. I have forgotten that we have to test continuity at x is equal to pi. Mistakenly I have taken x0. Now I am taking x pi plus. Pi plus means what? Means greater than pi. I am taking pi plus. It is what? Minus sin x. And we know sin pi is 0. So the final result is 0. For left hand limit, we have to add what? At the point x is equal to pi. So I am taking pi minus. Okay. Fx, it is what? It is pi minus. When x less than pi, it is what? It is sin x. And also we know the value of sin pi is 0. Now for functional value f pi, we know the value of sin pi is 0. Since as LHL, RHL functional value, left hand limit, right hand limit functional value are equal, so the function is different. So the function is continuous at x is equal to pi. And you can observe from this figure also, this is a continuous figure. Okay, and further I will not solve the continuity. I will solve only the differentiability conditions. Okay. In question number 7, fx is equal to x sin 1 by x not equal to 0. And when x is equal to 0, it is 0. And we have to test the continuity and differentiability at x is equal to 0. Here I am doing the continuity again. Left hand limit, first you have to find limit x for x is at x is equal to 0. We have to take limit extends to 0 minus of fx. Limit extends to 0 minus. in place of fx you have to write x sin 1 by x. Now there are two things. What are they? This is x and that is sin 1 by x, and you have to separate it. And this type of problem I have done it earlier. You can see. Now this is a limit extends to 0 of x, it is 0, into limit extends to 0 minus sin 1 by x. When you put x 0 here, it becomes minus infinite, and the value of sin minus infinite, it lies between minus 1 to 1, where we do not know. But when we multiply a value which lies minus 1 to 1, means whatever it half, it may be 1 by 3, it may be 1 by 7, well, whatever it may be. When we multiply it 0, it gives result 0. Okay. Now, exactly in similar manner you can do and find the right hand limit is 0. Now the functional value it is given, it is what? 0. Since the left hand limit, right hand limit and functional value are equal, I am not written it, I am not writing this thing here, you will write. If as the left hand limit, right hand limit, functional value are equal, so the function is continuous at x is equal to 0. But our main point is to find the differentiability of this function. Now left hand derivative. Left hand derivative, as you know, is what? Left hand derivative is, sorry, I mistakenly written it. It is f dash 0 minus. It is f dash 0 plus. Okay, mistakenly I have written that. It is by definition it is limit h tends to 0 plus f 0 minus h minus f0 by what? Minus h. Mind it, it is important. Limit h tends to 0 plus f minus h minus f0 by minus h. When you put f, what is the value of f minus h? fx is what? X sin 1 by x. When you put minus h, it is minus h sin 1 by minus h. I am writing it minus h sin minus 1 by h by divided by minus h, and it is 0. So no, there is no, it has no value. So you can cancel minus h minus h. Now result is sin minus 1 by h. When you put h tends to 0 plus, it becomes minus infinite, and sin infinite value we do not know. It lies between minus 1 to 1, exactly where we do not know. So we can write does not exist, as no exact value. Similarly here we can do this problem like that manner, and we should write the value does not exist as no exact value. Since you can say, sir, here it does not exist, here it does not exist. So they are equal. So the limit, so the left hand derivative is equal to the right hand derivative. Why you are writing here left hand derivative is not equal to right hand derivative? I am telling you small 2 lines to 4 lines story. एक स्टोरी ऐसा है, एक आदमी ने पूछा कि जो चिट्ठी जा रहे हैं छोटा सा, उसका वजन क्या है? तो ज्ञानी ने बोला मुझे पता नहीं। तो फिर एक कुछ समय बाद एक हाथी ने गया, उन्होंने पूछा हाथी का वजन क्या हो सकता है? उन्होंने बोला, ज्ञानी आदमी ने बोला मुझे पता नहीं। तो जो उसका जो स्टूडेंट्स था वो लिख दिया मुझे पता नहीं इज इक्वल टू मुझे पता नहीं। सो चींटी का वजन मुझे पता नहीं, उन्होंने बोला था चींटी का वजन। सो चींटी का वजन इज इक्वल टू मुझे पता नहीं बोला था क्या, किसमें? हाथी का वजन में। सो मुझे पता नहीं का नीचे लिख दिया चींटी का वजन, इज इक्वल टू मुझे पता नहीं का नीचे क्या लिख दिया? हाथी का वजन। सो चींटी का वजन इज इक्वल टू हाथी का वजन। सो वजन वजन कैंसल, सो चींटी इज इक्वल टू हाथी। As in that manner, if we will tell it does not exist, it does not exist. मुझे पता नहीं, मुझे पता नहीं. So they are equal. अरे मुझे पता नहीं. You should think you do not know the value. Then how you will equal? You will equal to known things. You can never equal to unknown things. So as it doesn't exist, as it doesn't exist. So left hand derivative is not equal to right hand derivative. So the function is not differentiable at x is equal to 0. Before solving this problem, I am telling you a very interesting thing which is not in your course, but I am telling you slightly about it. It is the L hospital rule. What is that? I am just going to 3 examples. Limit x tends to 0, sin x by x, and you know it is 1. But in L hospital rule, you just put here 0. Sin 0 is what? 0. 0 by 0, it is in 0 by 0. So for this limit, nothing should be done. Just differentiate the numerator and differentiate the denominator. It is what? It is cos 0 and the result is 1. Very interesting. Now again I am doing just 2 to 3 problems. Suppose limit x tends to 0, ln 1 plus x by x. You know it is 1, it is formula. And when you put x 0, it becomes ln 1, and you know it is 0. Then the denominator is 0. And by L hospital rule, the rule says just you have to differentiate the numerator 1 by 1 plus x whole divided by 1. Then put x is equal to 0. 1 by 1 by 1. It's totally 1. Okay. Now look at another problem. Limit e to the power x minus 1 by x. You know it is 1. Now put x 0. It is 1 minus 1 0 by 0. Just differentiate. Limit x tends to 0. E to the power x, derivative e to the power x. And derivative 1 is 0. Derivative x is 1. Put x is equal to 0. E to the power 0 by 1. Result is 1. Okay. It is also a problem is also there for infinite by infinite. Suppose x square minus 2x plus 3. Suppose it tends to infinite by 3x square plus 4x plus 5. When suppose it is plus 2. So when you put infinite, it becomes infinite. When you put infinite, it also put infinite. And for limit, you have to divide x square in numerator, denominator, then you will solve, which is in 11th class. Now in this, by applying L hospital rule, this is 2x plus 2 by 6x plus 4. It is what? When you put infinite, it becomes what? And the derivative 3 is 0, 5 is 0, not written. Derivative, when you put infinite, 2 into infinite plus 2, infinite. Denominator also infinite. When you put infinite, now it is infinite by infinite form. Again you can differentiate. You can differentiate once, twice, thrice, whatever times it is in the form. Now it is 2 by 6. The result is 1 by 3. I am applying this L hospital rule here for your easy and convenient way. Other method is very difficult, and this method I think it is very easy for you. Still then it is long. Now look at what is left hand derivative. It is f dash 0 minus 1. The only critical problem is number 8. Mind it. F dash 0 minus limit h tends to 0 plus f 0 minus h minus f 0 by minus h. You know it earlier. It is f minus h minus 1 by minus h. Till these two lines you can do. Now look at what is f minus h. Just put minus h in place where the x is. Where the x you put minus h means 1 1 minus e to the power here it is what? Minus x. You have to put here what? Minus h. So it becomes what? Plus h. Look at here. You put minus h. It becomes minus h. Then minus 1 by minus h. Yeah, when you take LCM minus h, 1 minus e to the power h, it becomes plus h by minus h. You have to divide minus h, so into 1 by minus h. The result will be what? 1 minus e to the power h plus h by h square. Minus h into minus h. It becomes h square. Now, for h tends to 0 plus, you put just 0 in numerator and denominator. It be when you put 0, 1 minus e to the power 0 is what? 1 minus 1, 0 plus 0. Again it is 0. When you put 0, it is 0. Now this is in 0 by 0 form. As the problem is in 0 by 0 form, what you have to do? You have to differentiate it. Differentiate. It becomes derivative 1 is 0. Derivative e to the power h is e to the power x. Before it minus is there. And derivative h is 1. And derivative h square is 2h. Now it is in 0 by 0 form. Now you differentiate. As it is in again in 0 by 0 form, you can differentiate it again. Now the result is e to the power h. Its derivative with respect to h. Mind it. Whatever it is written with respect to this. So it with respect to h is e to the power h. Minus sign is there. Derivative 1 0. And 2h derivative of 2h is 2. So the result is minus half. Now for the right hand derivative, look at there. F dash 0 plus. It is the definition. Now it becomes what? Just you write h in this place. It is here. Minus 1 by h. Now after simplification, this becomes this. And when you put 0 here, it becomes 0 by 0. Now for 0 by 0, what you have to do? Differentiation. It is 0. It's differentiation. Mark it. E to the power minus h into derivative of minus h. It is minus 1. So it becomes plus. Plus e to the power minus h. And derivative h is what? 1. So minus 1 in by 2h. Again when you put 0, it becomes 0 by 0. 0 by 0 becomes, okay, it becomes what? E to the power, when you put 0, e to the power 0, 0 by, it is not written again. So it becomes limit h tends to 0 plus e to the power minus h. Its derivative is minus e to the power minus h. Derivative of 1 is what? 0 by what? 2. And when you put x is equal to 0, it becomes minus 1 by 2. Now, in both cases, left hand derivative and right hand derivative are equal. So I will write as left hand derivative is equal to right hand derivative. So the function is differentiable at x is equal to what? At x is equal to 0. So fx is differentiable at x is equal to what? 0. Point. Practice it twice, thrice, 4 times before exam. Now look at this problem. It is a different style problem. The test of question says it is your fx. Question says test differentiability. Test differentiability of fx is equal to x square minus 4 modulus. The points are not mentioned here. You have to mention, you have to solve. Now what is fx? Is x square minus 4. When x square minus 4 greater than equal to 0 or x square greater than equal to 4. Minus of x square minus 4. X square minus 4 less than 0, x square less than 4. Now look at this point. X square greater than 4. Where? And x square less than 4. X square greater than 4. So when x square is equal to 4, mark it. What I am telling you. When x square is equal to 4, it gives you 2 points. What is that? That is minus 2. This should be on your left, and it is plus 2. This should be on your right. Now tell me, when x square greater than equal to 4, then I am taking value minus 1, 0, it is minus 1, it is minus 1, it is 0, it is plus 1, okay. Then what? 3, 4, 5, so many values. So put when x square, where x square is greater than 4, when I will go to the right, means I will put 3 square greater than 4, 4 square greater than 4, 5 square, 25 greater than 4. When I will go on the right of plus 2, I will get x square greater than 4. And also when I will go to the left of minus 2. Left of minus 2. What will happen? When we will go right of 2, x square greater than 4. When we go left of minus 2, we will get x square greater than 4, greater than equal to 4. So in place of x square greater than equal to 4, I will take x greater than equal to 2, x less than equal to 2, and we know it is what? Fx is what? X square minus 4. X square less than 4. X square less than 4 means x must be when x is minus 1, x square less than 4. When x is 0, x square less than 4. When x is 1, it is what? It is also less than 4. So when I am taking values inside minus 1 to minus 2 to plus 2, when we take x within minus 2 to 2, x square is less than 4. So in place of x square less than 4, we have to write minus 2 less than x is less than 2. In place of x square greater than equal to 4, we have to write x greater than equal to 2, x less than equal to minus 2. Now I am writing in 3 stages. What is when x less than minus 2? When x less than minus 2, it is x square minus 4. Okay. When x minus 2 to 2, it is minus x square plus 4. When x greater than 2, in that side, it is greater than 2, fx is equal to what? X square minus 4. Okay. Now I am taking the differentiation. F dash x. It is 2x. It is minus 2x. It is 2x. So you should not put the equal signs. You should not put the equal sign. That is the critical thing. You should not put. Now look at. There are in which point you have to test. You have to make the test at the point, junction point, that is minus 2 and plus 2. Now f dash minus 2. Now f dash minus 2 minus. When x, that means x less than minus 2. So you have to take this. That is, you have to write fx, but you have to put x is equal to minus 2. You have to put x is equal to minus 2 in place of what value? In place of this value, and it gives you minus 4. F dash minus 2 plus means minus 2 से ज़्यादा f dash कौन सा value है? Minus 2 से ज़्यादा, थोड़ा ज़्यादा means this. You have to write minus 2x and you have to put x is equal to minus 2. Result is plus 4. As they are not equal, so f dash x does not exist at x is equal to what? Minus 2. Now f dash 2 plus. What is f dash 2 plus? It is 2x. Why? 2 plus means you have to take 2x and put the value, you will get 0. For f dash for f dash 2 what is f dash 2 minus? 2 minus means थोड़ा सा छोटा है, 2 से थोड़ा सा छोटा है. It is minus 2x and you have to put x is equal to 2. You have to put 2 in both cases. But what you have to take? You should very much careful about it. So the result is minus 4. So in both cases, it does not, the f dash x does not exist. Okay, and you should practice these problems very carefully for your exam. It is very easy method for you. Now look at the graph of this. Graph of fx is equal to x square minus 4 modulus. X square minus 4 modulus is this. I am doing the graph. Look at here. Very, very interesting thing. Just I am putting, when you put x is equal to minus 2, you have to put here minus 2, it becomes minus 2 square 4. 4 minus 4, it is 0. It is not necessary, mind it. It is not at all necessary for your exam. But I am explaining you and giving you very interesting thing. And when you put x is equal to 0, means you have to go to this area. You put x is equal to 0. When you put x is equal to 0 here, because 0 lies between this to this, you will get what? 4. 4 means it is positive. When x 0, it is 4. Put x is equal to 2. when you put x is equal to 2, it becomes what? 2 square minus 4. It is 0. So it lies here. For minus 2 it is 0. For plus 2 the result is 0. When x is equal to 0 the result is 4. When you will take 3, what will happen? 3 means 3 greater than equal to 2. In this part you have to put 3 square minus 4, that is 5. 9 minus 4, 5. You will go up part. When x you will take minus 3, what will happen? You have to put here minus 3 square is 9 minus 4, 5. It is also. So this figure becomes, when you go left, it becomes this. When you lie in between minus 2 to 2, it becomes this. When you go beyond 2, it becomes this. Now you should observe the point where the function is not differentiable. Look at here. The curve is coming like this and suddenly changes its path. So at this point it is not differentiable. But it is not the sudden path. It goes like this. Max curve goes like this. It is not the point. Here the point. It goes down at 2, but suddenly pick up. Goes down, then suddenly pick up. At this point, the function is not differentiable. Also look. At this point, the slope, when x tends to minus 2, when take the smaller value, when x tends to minus to minus means negative, the slope is negative. Look at here. When you will go minus to plus, slope is what? Slope is positive. Here in this, when you go to minus, slope is what? Negative. When you go to plus, slope is positive. Here slope changes from negative to positive. Negative to positive. Okay? When slope changes suddenly from negative to positive, at that point also the function is not differentiable. I am telling you repeatedly, sir, you have done the graph here, you have done graph of sin x, mod sin x, you have done graph of some extra mod x, but why you are not drawing all the graphs? Don't take bother by drawing all graphs. But also, don't try to forget all graphs. Take some knowledge from the graph so that it will very, very interesting for you. If you will take every graph, it will be headache for you. Okay? This is the last problem and it's a very tricky problem. Mark it here. Fx is equal to x minus 1 mod plus x minus 2 mod plus. So you have to test the differentiability only. At which points it is not mentioned. The point you have to mention. How you have to mention? Mark it. Put it 0. X becomes 1. Mark it x1. Put it 0. X is 2. Mark it x2. Now make a number line. How many parts are there? 3 parts. Part 1, part 2, part 3. In this part, x is less than 1. In this part, 1 is less than x is less than 2. In this part, x greater than 2. For this left part, extreme left part, where x is less than 1. In this part, x less than 1. So in that case, you have to x less than equal to 1. What you have to write? Take minus of this and also minus of this. Because for this part, x less than 1. For this part, x also less than 2. And you know, modulus of anything, when it is less than 0, is minus of that thing. When modulus of anything, when this part is less than 0, when you lies in between in the left of 1, it is also less than 2. So it is minus of this. So it becomes what? After expanding, it becomes minus 2x. After opening, it becomes minus 2x plus 3. Now the middle part. In this part, x, when x lies between 1 to, so 1 to 2, 1.1, 1.3, 1.9, 1.7, like this. X must be greater than 1 and x is less than 2. As x greater than 1, x greater than 1, So what we have to take? We have to take x minus 1. When x less than 2, it becomes minus of this. Minus of this means minus of what? Minus of, I am writing it, minus of x minus 2. It is minus of x minus 2. Minus x minus 2. After opening, it becomes 1. Okay, I am not taking equal sign here. Equal sign here and here. When x greater than 2, when x greater than means this part, it must greater than 1. And it is also obviously greater than 2. It becomes what? When x greater than 1, it becomes x minus 1. When x greater than 2, it becomes what? X minus 2. And after opening it, it becomes 2x minus 3. So fx is what? Minus 2x plus 3, x less than equal to 1. 1 when 1 is less than x less than 2. 2x minus 3 when x greater than equal to 2. Now what is f dash x? Its derivative minus 2, its derivative 0, and its derivative is 2 when x less than 1, when 1 less than x is less than 2, when x greater than 2. Now what is f dash 1 minus? When x is slightly less than 1, what is f dash x? Minus 2. When x is more than 1, it becomes what? 0. So as f dash 1 minus is not equal to f dash 1 plus, so the function is not differentiable at x is equal to 1. Now for f dash 2 at x is equal to 2, f dash 2 minus is what? 0. And f dash 2 plus is what? 2. So f dash 2 minus is not equal to f dash 2 plus. So the function is not differentiable at x is equal to 2. Lastly, I will do the graph of this function. Look at me. It's very easy. Don't think it's difficult. But there is no need to draw at your exam paper. But you should know what happens here. Take number line. Take 1. Take 2 here. Okay. This is your y-axis. When you put 1 here, it becomes what? 1 minus 1, 0. It becomes 2. 2. When you put 2 here, it becomes 2 minus 1, 1. And 2 minus 2 is 0. It is also 1. At 1, the value is 1. Because 1 minus 2 modulus is what? 1. When x you put 2, it becomes 1. So the graph is like this. Okay. In each place, the height is 1. Suppose you are putting 1.3. 1.3 minus 1 is what? 0.3. 1.3 minus 2. That is minus 0.7. Its modulus is 0.7. So 0.3 plus 0.7 is 1. In each place from 1 to 2, it gives you what? The value, it gives you 1. When x is more than 2, suppose I am putting 4. 4 minus 1, 3. 4 minus 2, 2. It becomes 5. That is going to this direction. When we put x is equal to 0, it becomes 0 minus 1 is what? 1. 0 minus 2 is 2. The result is 3. So it goes to this direction. Now this is just a bucket-like structure. And you can observe, look at, very interesting thing. You should not write for the exam. I am telling you very interesting thing. Where the path is sudden, where the curve suddenly changes its path. Coming, suddenly changes at 1. And also at 2, suddenly changes its path. So, not differentiable at x is equal to 1, 2. Very, very interesting thing. Secondly, mind it. When x less than 1, this slope is towards, this line is inclined towards left. So, its slope is negative. When x greater than 1, it is parallel to y-axis. So, it is 0. When x less than 2, 2 minus, it is parallel to x-axis. So its slope is 0. When x is more than 2, what happens? Its slope, it is inclined towards right. So its slope is positive. Mind it. When a line inclined towards right, its slope is positive. Incline towards left, slope negative. Mark it. What happens? At this point, for these points, left hand, the left side slope and this point's right side slope, both are different. For this point, the left side slope, the right side slope are different. When they are different, at that point it is not differentiable. Okay, it is. You have to understand it only properly. It is not for exam paper to write this graph and this explanation. Only this one. And I am telling it is a differentiability, the test of differentiability in different style. And you will observe at the time of exam what's the value of this pleasant mathematics video.